if rows or columns are interchanged. The rows are changed into columns or columns are changed into rows. Rows or columns are interchanged or rows are changed into columns or columns into rows or columns into rows. There is no change in the value of determinant. The value of the determinant does not change. What is that? Is it transpose? Transpose of a determinant, if it is done, okay, then the value of the determinant doesn't change. For example, if A is a matrix, let me take, if let A is a square matrix, then the value of determinant, how it is represented, value of determinant, we write either this in the form of this A, or simply write determinant, then determinant A. Okay, this is symbol for this determinant A, or value of A is equal to A transpose determinant. If I find out determinant of the transposed value, this is equal to the same. No change in the value of the determinant. For example, let me take simple example here. Our determinant, let me take A is a square matrix of order 2, 2, 3, 1, 4. No problem. This is this one. This is of order 2. A square matrix. Of order 2. Then what is the determinant value of this? Then determinant value of A, how it is calculated? Just by cross multiplication. It is 4 to the 8 minus 3 to the 3. It is 5 only. Answer is 5. This is value of determinant A. Okay, now let me take transpose of this first. A transpose. Now transpose of A is equal to A transpose, which is written down as writing rows into columns, or interchanging rows into columns or columns into rows. It is 2, 3 and it is 1, 4. 2, 3 is written as a column. First row as first column, second row is the second column, second row as the second column. Okay. Now what's the answer here? 4 to the 8 again. 8 minus 3 again 5 on 2. Okay, so what do we see? This implies that determinant value of A is equal to A transpose determinant. Same answer. This is the first property we have taken here. Okay, so property number 1, we have taken one illustration here. We have seen that after interchanging the rows into columns, the value of determinant doesn't change, they are the same. Determinant value of A is equal to the transposed determinant value of the transpose of A. Same answer. This is question property number 1. Now let me talk about one more property, second property. What is property number 2? Property 2 of second property. Let me write it down. If two rows or two columns are interchanged, then the value of the determinant is changed. If two rows or two columns or two columns are interchanged then this is in case of square matrix of order 3, order 4, etc. Okay, in case of order 2, it can be interchanged. We can interchange the order into columns, answer will be negative. Okay, if two rows or two columns are interchanged, then the value of the determinant will have different sign. The value of the determinant of it will have a different sign. Will have a different sign. That means sign will be changed. If it is positive initially, then it will be negative. If it is negative, then it will be positive. Let me take again example. Let me take again a square matrix. A is 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 a square matrix. Let me take again 2, 3, 2, 1, 4 here. If I interchange the two rows, this is A here. So interchanging the two rows, interchanging the two rows. First its value is what? 8. 8 minus 3, 5. This is what we have calculated. If I interchange the rows into columns, sorry, the rows, the two rows, this row is written as second and this as first. What is that? This is 1, 4, this is 2, 3. What is the value here? This is 3 minus 8 is minus 5. This we have seen here, this is negative 5. So previously it was plus 5, now it is not minus 5. What we have done, we have interchanged the two rows. First row has written second row and second row has been written as first row. We see that answer is different. It's a negative sign. Or if columns are interchanged, let me change the columns. Let me take this B here. Let me take C after interchanging the columns. If I write the columns here, this is 3, 4. Second column has been written first column. This is 2, 1. 2, 1. First row, first column has written second column. This suppose C. What is the answer of this? 3 1 is 3. Cross multiplication minus this minus 8. This is equal to minus 5. What we see here? Either we change two columns or two rows of any determinant, answer will be of different sign. The determinant value will be changed into negative or positive. The sign will be different from that of the first one. This is what the second property is. Okay, this we have explained here. Now let me take the property number 3. So property number 3 here. Property number 3. If every element of a row, if every element of a row or a column is multiplied by a scalar quantity, then the value of the determinant will multiply that quantity. Then the value of the determinant will be multiplied be multiplied by that quantity, by that scalar, by that scalar quantity. Same thing is there. Let me just take one illustration. Okay, let me take here that if A is a square matrix, again I'll take a simpler example. If A is a square matrix, if A is a square matrix, okay, is a square matrix of order 2, then A is again, let me take, this is a square matrix here I'm writing, 3, 2, 4, 5, let me write, no problem. If I multiply this by a scalar quantity, let me take multiplying by K. Okay, therefore A into K is equal to K multiplied to the first quantity, not multiply this AK, but let me multiply this by 3K, this 2K. The first row has been multiplied by K, the scalar quantity, where K is a scalar quantity. 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 Okay, where K is a scalar quantity. But the answer in the first one, if I find this determinant here, let me write in determinant form. A determinant is equal to 5 3 are 15, this is 15 cross multiplication, and then minus this is 8, which is positive 7 plus 7. In the second case, determinant A here in this case, this is, let me take B. After multiplying by scalar quantity K, this is 3 5 the 15K. 15K minus 8K. What we see here, this is 7K. So this quantity is multiplied by K. The determinant value is multiplied K. If any row or any column, if it is multiplied by a scalar quantity, then the value of the determinant is multiplied by that quantity, by that scalar, by that scalar quantity. So this is K here I have taken. You could take any numerical value also in place of K. I could also prove this, that this is the proof. The third property we have taken here. Okay, now let me mark here. This is property number 3. Now let me take fourth property. If any two row or two columns are same, or they have the similar quantities, similar elements, then the value of the determinant is 0. Let me write here. This is property number 4. If any two rows or columns are identical, or they have the same quantities, same elements, I mean. If any two rows or columns are identical of a matrix, of a square matrix, in this case it's square matrix here, of a square matrix, then the value of the determinant will be 0. Then the value of the determinant, will be 0. Okay, so if the value of determinant is 0, that means if any two rows or columns are same. Now if in a square matrix of order 2, it's very simple, we can prove it very easily. Okay, if let me take A here, having the same rows and same column, this is determinant value. So if I write A only, then write matrix form. This is matrix here. A square matrix, let me take this is 3, 4, this is also 3, 4. Same rows have the same quantity, answer is 0. Why? Because this is 12 minus 12, 0. Simple illustration is simple. If it is of 3 order and 2 rows and 2 columns are same, if let me take B is a matrix of order 3, if it is 1, 2, 3, 1, 2, 3, 4, 5, 6. Now third row is different, but first 2 rows are same. What the answer of this? Answer is 0. Let me just calculate. How it is calculated? This I have defined, and I am taking here what is the determinant of a square matrix of order 1, of order 2, order 3. This is of order 3. How do we calculate this? With the help of determinant or with the help of cofactors. I just note down. This answer of this determinant will be, so here let me write B. Determinant value of B is equal to, this is 1 into, we write here cofactor of 1 is cofactor this. This is 2, 3, 5, 6. Let me write in minus 5. This is minus sign here as well because this is 2. 2 is lying in the first row and second column, so 1 plus 2 is negative. This 2 into, so this and this first row and second column is left, and the remaining values are 1, 3, 4, 5. Sorry, 4, 6. I'm sorry. This is 4, 6 here. 4, 6. Then plus 3. Therefore, value is this and this row, first row and third column is not considered. The remaining values are 1, 2, 4, 5. So the final value of this is 6 2 are 12. 1 into 12 minus 15. 12 minus 15. Minus 2. This is 4, 6, 1 is 6 minus 12. 6 minus 12 here. Plus 3 into, this is 5 1 is 5 minus 8. Okay, so this will give us 12 minus 15 is minus 3. 6 minus 12 is minus 6 minus 6 to the 12. It is plus 12. Then plus 3. 5 minus 8 is minus 3. Minus 3 is 9. This is minus 9 here. Minus 9 minus 3 is plus minus 12 and plus 12 minus 12 and plus 12. Answer is 0. What do we see here? Answer is 0 here. Is the answer. Same answer. Of order 2 or of order 3, if any 2 rows are same, identical, or 2 columns are identical if I write, then also answer is the same. This is the property number 4. Only these 4 properties are taken. Okay, there are other properties. We will discuss them in detail. Take a number of illustrations, number of questions I will based on all those properties in next lecture series. So only 4 properties I have taken of determinant. There are about 12 properties, but applications are also there. Okay, so these are the 4 properties I have taken. Question number 4. Okay, so these properties are very much clear now. Let me take question number 5. What is the determinant value of order 1? Determinant of the order 1. What is the value of that determinant? How that value is calculated? Okay, so how do we calculate that value? Now it says, what is the determinant of a square matrix of order 1? This is question number 5. Simple question. So this is a square matrix. A square matrix of order 1. Of order 1. Okay, of order 1 or 1. So this can be written as A, let me take A I J matrix is equal to A11 only. This is one element it is having. This is the matrix of order 1. This is 1 by 1 matrix, one row and one column. Only one element is there. What the answer of this? Simple answer. A11 is equal to A11. This is the numerical value only. And if I take that this is a numerical value, let me take 3 here. This is the matrix. The answer is determinant value of this. This is 3 only. Okay, so determinant value of this AA, or this implies that determinant value A, this is suppose A is equal to 3. The determinant value of A is equal to determinant 3, that will be 3 only. Only the value is there. In case of determinant of matrix of order 1, square matrix of order 1 is the value itself, that numerical value itself, the answer. This is question number 5. If whatever the value is given, that will be, means one element will be given, that is the answer only. Determinant is the same element, which is the okay, that is square matrix. That is square matrix of order 1, that means only one element is given. What is a square matrix? Second day. What is the determinant of a square matrix of order 2? Let me write now. Question number 6. Determinant value. How do we calculate that? Determinant value of a square matrix of order 2. Okay, so let me take solution here. We are calculating. As I was just calculating there, that if A is a square matrix, let me take here A11, A12, A21, A22, 4 elements. How do we calculate the answer? Therefore, determinant of A in this case will be, we cross multiply this. First we write A11 into A22. We put minus sign in between, cross multiply to these two. A21 into A12. This answer here. Let me take a numerical value. Let me take B in place of B. Let me take B here. So this is the matrix 3, 4, 5, 6. No problem. But the answer here, so determinant value of B will be 6, 3 are 18. This is 3 into 6 minus 5 into 4. That means 18 minus 20. That is minus 2. The answer. Just value of determinant of a matrix of order 2 is we cross multiply them and put minus sign in between when we write this non-diagonal values. This is main diagonal value or leading diagonal value. We multiply them with positive sign, and the non-diagonal values which we write is negative sign here. This is negative sign. This is the answer final. Just we cross multiply. This is determinant value of a square matrix of order. This is how we calculate the determinant value of a square matrix of order 2. Now let us take a square matrix of order 3. Submit question. Let me clear this. Give us clear view. Okay. Question number. Okay. And let us take next question number 7. Now, 7th question says that what is the determinant of a square matrix? Determinant of a square matrix of order 3. Let me take determinant of a. This is determinant of a square matrix of order 3. Okay, let us take, because this I am already explaining with number of times. I have already explained this, but let me again write it down. A11 A12, A13, A21, A22, A23, A31, A32, A33. So how do we find out the value? With respect to the elements lying in the first row, we explain or we write the cofactors of that. So answer of this will be A11 into cofactor of A11 plus sign, A12 into cofactor of A12 plus sign, A13. This is the answer of determinant value of A. This is we are calculating determinant value of. The answer of this determinant of value of A will be this. This is solution we are calculating. Solution here. How determinant value of this is calculated? We write A11 the number of that element here into cofactor of this A11. We will write A12 into cofactor of A12 plus A13 into cofactor of A13 into cofactor of A12, A13, sorry. This is A13, cofactor of A13. So what is the answer finally? A11 into what is cofactor of this? This is minus 1 raised to power 1 plus 1 into minor. Now in this case we write minor of this. A12 is A22, A23, A32, A33 plus sign. We write here A12 into minus 1 raised to power 1 plus 2 into determinant value of A12. We have write here A21, A23, A31, A32, A33, sorry. This is A33. Then A13 into minus 1 raised to power, let me write here minus 1 into minus 1 raised to power 1 plus 3 into determinant value. This is A21, A22, A31 into A33. So these are the values of this. Minus 1, A13 minus 1 is power 1 plus 3 is the value here. What is the final answer? Okay, so this is what we calculate. Now cross multiply, this is of order 2. Now order 2 below, cross multiplying this minus this, cross multiplying this, but this will be negative. Why? Because minus 1 is power 1 plus 3 is negative. So let me write here final answer. This is A11 into A22, A33, this minus sign, this is A23 into A32, then plus, or this is minus sign here. Minus 1 is power, this will be negative. This is minus sign A12 into A21, A33 minus sign. This is A23 into A31. Then plus sign, this value, this is A13, this one. This is plus sign because 1 is for 4, minus 1 is for 4 is positive. This is plus sign into A21 into A33 minus sign A22, this one, into A31. Okay, so this will multiply it. Finally, this answer will give us the answer. So let me further write the final answer. This is how we calculate the value. This will be A11, A22, A33 minus sign A11, A23, A32. This value with negative sign minus sign A12, A21. This is A33 plus sign now minus plus. It is now A12, A23 into A31 positive plus sign. This is A13 A21, A33 minus sign A13, A13, A22, A31. Okay, so these are the, after solution you will find out this answer. Is there any similar values which can be cancelled out? A13, no. Okay, solution of this answer will give us a final answer. Okay, so this is how the process of multiplication, the finding a determinant of a matrix of order 3. This is the process here. Okay, so this is for, if I take numerical value, we can calculate that easily then. Let me take one numerical value. If I take of order 3, any matrix, let me take that matrix B, this is matrix B here. Matrix B of order 3 to this, let me take 2, 3, 4, 5, 1, 2, 3, 4. No problem, nothing is similar. For the answer here, we add 2, this 2 into this multiplication. This is 5 4 is 20, minus 3 1 is 3, minus sign in between, because this is lying in the first row and second column. So 1 plus 2, 3 negative. Minus 2, this is minus 2 into, of this column is left, this row is left, this is 4 into 4, 16, minus 3, 2 1 plus sign 3 into this 3 into remaining numbers in the remaining columns and rows. So these two rows are left. This row is not considered, this column is not considered. It will be 4, 3 is 12, minus 10, 5 to get 10. The final answer is 20 minus 3 is 17, the 20, 34, minus 16 minus 2 is 14, 14 to get 28, plus this is 2, 12 minus 10 is 2, which is 6, 6. 34 plus 6 is 40. 40 minus 28 is 12. Answer. Final answer is 12 here. This is how 34 plus 6 40. 40 minus 12, 28. 40 minus 28 is 12. Answer is this. This is how determinant of a matrix of order 3, the square matrix of order 3, is calculated. Now let us talk about square matrix of order 4 and more. What is